Okay, so welcome everyone to the RMDS data competition webinar. So in this webinar, we will lead you through the dataset you will encounter in the competition. And so we invited Dr. Su Hui and Dr. Long Tao from the JPL lab. They will give introduction of the dataset and feel free to ask them questions. And also my lovely colleague, Alicia, the web platform manager, will give you a short demo on how to submit your login, register, submission of projects. And if you have any questions in this process, also feel free to ask her. Okay.
Great. Okay, thank you, Cici. So this is Alicia, and I want to welcome everybody to our data science competition. This is the training session that will be provided by our lovely colleagues as well as partners and expert panelists. And so I want to get started with introducing you guys so all of you guys already signed up for the data science competition. That's how you receive the link for this invite. But I want to go through the process of really making sure you know how to get the training data set, the test data set, how the submission process works, where you can receive the information and help that you need. So let me get started by sharing my screen and going to our website. And if there's any questions that you have, just write them down. And then at the very end of the session, we're going to have a Q&A from the audience. But before then, we're going to first go over the website. Then Dr. Su Hui and Dr. Long Tao are going to go over a PowerPoint presentation that they've prepared. Then we're going to have a Q&A based on the most commonly asked questions, and then we'll open it up to the audience. So let's get ahead and get started. So you can see here that most people, when you log in, this is what it looks like. This is my one of my accounts, and if you go to the competition page, you can see here that the submissions are due in November 25th, so in 20 days. And if you already have your data set, you can get it here. You can also go to, so let's just go over this page a little bit. You can get some information here about the timeline. As you can see here, today's live training session is there. It's due on the 25th. And right here is also quite important. So you can also get the data set over here. It links to the same page as the banner above. But what's important here are the research paper for the Kaplan research paper. It's very important that everybody reads this because it gives the context of the existing model that is currently being used, as well as how we can improve it. And in this data set, FAQ guide is also quite important because it's a .nc file, and I know that some people may not be very familiar with spatial data. So this will give you some, like an intro to the data description, how to download, how to open, how to evaluate it, and various others. So there's also kind of code that you can use here, evaluation method, and if you need to contact someone, of course, you can contact CC right here. Okay, so let's kind of go back to our page. So let's go to download our data set. So you can see here, we can download here, and it'll direct you to the competition data page. So you can also access it directly by sharing this link with your friends. So here we have the competition data, we have the training data set and the test data set. If you click on them, just confirm, you'll be using this only for competition. Say yes, and it'll start downloading. The same thing with the test data set, and they're zip files, so you can just, after it's finished its download, you can unzip it. So that's pretty straightforward to get the data set. And then in terms of if you have any questions about it, like I said before, if you go to the data set guide from the previous page, the PDF, you can get it there. And then when you're ready to submit, you want to go under resources and project. So each team should have one submission, whoever is representing the team. But every team member should have an account. That way you can recognize each other as team members and collaborate on these together.
Okay, so let me get into the presentation mode. Okay, so I'm gonna talk about the data set we provided for this competition. So this data set actually is focused on the data we use to forecast hurricane intensity
in terms of the wind speed. So like when you have hurricane, you have this kind of cyclonic system, and we use the maximum wind speed near the surface to indicate the strength of the storm. So the prediction of the hurricane intensity is actually extremely challenging. So we still have a lot of problems in accurately predicting the intensity change. So this is a very is a top priority in like a research community to improve the hurricane intensity, because it actually any improvements in the hurricane intensity forecast would be associated with like reducing a lot of economic losses associated with landfalling hurricanes. So your like all the contestants, your role in like your task is to create a statistic model to predict the hurricane intensity change in 24 hours using advanced machine learning techniques. So in the competition, we define the tropic cyclone intensity. We particularly focus actually one special kind of intensity change. We call that a rapid intensification. It is defined as the wind speed change in 24 hours would be greater than 25 knots. So we provided the wind speed at every 6-hour interval. So you will predict the intensity change in the next 24 hours. But if the intensity wind speed change is greater than 25 knots, then that's called rapid intensification. So is that clear? Okay, so I'll go on. We provided two sets of data sets in the NetCDF format. One is called ships.nc. So this SHIPS actually is the stands for the Statistical Hurricane Intensity Predictions Scheme in the National Hurricane Center. Is actually is an operational statistical forecast model for tropic cyclone intensity. And we downloaded the historical data for the predictors they used for TC intensity forecast. So this we have data from 1998 to actually current, but for this competition, we'll use the years from 1998 to 2010 as a training set, and you build a model based on this 1998 to 2010 data, and then you're gonna test your model using the data from 2011 to 2014. So in this ships.nc, you'll see many one-dimensional parameters. So as this show on the right, so you'll see the date and also the TC intensity, that's the variable Vmax. So at this particular time, and we want the predictant for this task is called dvmax. So that's the Vmax change in 24 hours. So they both in the unit of knots. So 1 knot is about like a half meter per second. And you'll see other variables indicate like a C lat, C long indicates the center of the storm in latitude and longitude. There are also like many other parameters. So we have some definition for each variable. So they are pretty much self-explanatory. But if you have questions, you can ask us. And as there's another data set we provided called prcp.nc. So that's the precipitation data. It's actually, it's not currently used in the National Hurricane Center, but we think that contains a lot of information about the TC intensity change, and it could be actually like a new data set, the National Hurricane Center, if they adopt, then maybe have some added value to improve the hurricane intensity skills, the forecast skills. So this prc.nc actually is a two-dimensional data set. It represents the rainfall, the surface rainfall rate around the hurricane. So we label the data in the relative coordinate to the storm center. So you see the kind of two-dimensional array, and they have is a function of R lab and r long. So r length is relative distance in latitude respective to the storm center, and r long is the relative longitude with respect to the storm center. And the precipitation rate has a unit of millimeter per hour. So that's the data set. I think you would need a lot of exploration how you're going to use that data set to represent, to actually predict the TC intensity change. So we have multiple time slices for the precipitation data, like marked the R hour is the time that the precipitation was observed, like with respect to the storm location at the current time. So it's like a -12 means 12 hours before the that current time, or -9 or 9 hours. But we are using this data set to predict the tropic cycle intensity change from hour 0, like in 24 hours. So I think if you use multiple time slices, it might give you higher predictability. So we need to try that out. We haven't really done much research, like how those different time slices would be helpful in improving the TC intensity forecast. So this chart tells you our metrics to evaluate the model performance. So because we are predicting the rapid intensification occurrence, so if the occurrence is predicted as going to happen, and the actual observation, like the TC like RI happens or not. So you basically, you would have 4 scenarios for the outcomes. You could have a heat, like you predicted yes, and the actual event happens, or you could have a miss, like you predict no, but the actual event happens, and also false alarm and correct negativeness. So basically in the research community, we have 3 predictive scale. They are predict probability of detection, like POD. This is a percentage of accurate positive forecast out of the total actual events. And the false alarm ratio, and the pairs scale score. So we have the definition shown here, and the bottom chart shows the result, actually the current hurricane center's forecast scale in terms of the rapid intensification occurrence, like in terms of the PSS, POD, and FAR. So this represents state-of-the-art hurricane center forecast scale. This result is shown in the paper by Kaplan et al. So that's a paper we provided to you. So you can actually compare your model skills against this state of the art. But we want to point out, actually, this hurricane center like a predictive scale is based on their real-time operational forecast. So in fact, when they do the real-time forecast, they didn't have all this advanced data as we have. So you may see your score might be higher than theirs, but in fact, we give you better data. So just be aware, if you get better scale than the Kaplan et al., doesn't mean it's the best scale you can get, because you actually do have better data than the paper actually used. So, so here is talking about our evaluation skills. So we will evaluate your model performance based on primarily the PSS, because that's the overall performance score, kind of consider the high probability of detection and low false alarm ratio. But we want to point out, actually, the Hurricane Center particularly interested in this low false alarm ratio. So in the case we have two teams have the same PSS score, we would favor the team have a lower false alarm ratio, because that's one thing like Hurricane Center is really cares about. Okay, so that's all I have. Just give you a general overview of the data set. So if you have any questions, just feel free to ask.
Yeah, Dr. Suhui, I have a few questions here. Hope you can answer first. So first of all, as you introduced, this file is a .nc file. I think it's not very it's a special file that's mainly used for spatial data, I think. So can you give us an idea of what are the first steps to open this file and read the data from it?
So if you're using R or Python, there are a lot of standard reader to read the netcdf, right? So I think the netcdf file has a meta data, so it tells you the structure of the data or the units or scale factors. So if you use I think R or Python, they have functions, so you can read the netcdf. It's pretty straightforward. I think probably most computer science students will know how to open a netcdf.
Okay, yeah, I noticed that I did some research and noticed that in Python, we have this library called the netcdf4, I think we can use. Do you have some specific tools you would recommend, or it's just Python and R?
No, I don't think. If you use either software, you should be able to have a reader, like a function, I think.
Okay, cool. And is there any kind of data cleaning process would you suggest us to start off with?
I think in this raw data set, you might see a lot of -999. That's the marker we use to indicate missing data. So when that time slice has the -999, you can just ignore that. So just throw that data out.
Okay.
Because that usually means we don't have a good observation, or that the time slice data get screwed up.
Okay, cool. Thank you so much, Dr. Su Hui. So my colleague Alicia right now will show you guys how to do the submission of the file. And a quick reminder here, remember the deliverable at the end should include a CSV file of your results and a PDF of your report, your original source code, and anything else like analytical workflow you want to include. And for the CSV file, it should include timestamp dates like in year, month, date, an hour, and C-long, C-lab, predicted dvmax, and predicted RI, these values. This is also included in our, the document on the web page. You can find that in grmds.com/competition.
All right. Thank you, Cici. And thank you, Dr. Su Hui and Dr. Long Tao for that presentation. So kind of what Cici was mentioning earlier, just to remind you guys about the deliverables of how it's submitted. And then now I will go through the submission process with you. So let's go back to projects. So that falls under resources and projects. You can click to add a new project. So we can see here, so each team should have one submission. So project, you can put something like competition data or competition submission or anything like that, like team, ABC. And then you can put a little description for it. You can add a new file. So what we talked about before is we want this, so if we go back to competition, the deliverables, click on deliverables, we want to create a zip of the following, right? The CSV of your results, the source code, README file, and research report in PDF. So once you zip it all together, you can publish it here. Click on project type, ongoing, of course it'll be completed. And then you can also link the data set here. So there's a couple data sets here, but you can find the one that applies to our competition for competition data. So everybody should link this existing one. If you have any workflows to add, so this could be, any kind of diagrams, any kind of anything like that. You can add a workflow right here. You can add a new insight as well. So you should be, putting your reports under new insights, and some other things right here, such as the number of people impacted, number of collaborators, your project contribution. So if you were the sole contributor, you should put 100%. But if you had, let's say, 4 people on your team, then your contribution would be 25%. And then once you click this checkbox and click save, it will be published to our projects page, and we will be able to see kind of your CSV and your results over here. So that's, you know, the submission process, and it's pretty straightforward. If you have any questions, just go back to the competition page. All the information is over here, and of course, you can reach, you know, the RMDS team, specifically CC, at her email. So I'll hand it back to you, CC, for the next part of the session.
Okay, so next is a general Q&A session. So if any of you have questions about the data set or about platform, you can ask Alicia and Dr. Su Hui now. Please unmute your audio if you have any questions. So I think everyone is about clear about the process and data set. So we are glad that you are here for our webinar today. And remember, this is also recorded, so you will be able to view this for any further questions you have on our webpage, again, grmds.org/competition. And I'm Cici. If you have any questions related to other technical or submission things, please feel free to email me at cici@rmdslab.com. So I think this is for today. Thank you all for joining, and we look forward for your final work.
Thank you, Cici.
Thank you.
And thank you, Dr. Su Hui and Dr. Lantau, for your help.
Thank you. Okay. Bye. Good luck.
Bye.
Bye. Bye-bye.